Oh, hello. I'm going to revise today polygons, um, 3D objects, drawing nets, calculating surface area, drawing elevations of 3D objects, and yeah, that's and a little bit about angles. And yeah, that's about it. So let's start with the first one here. As you can see, the diagram shows a pentagon. We know from the pentagon that we have 5 sides. So n, which is the number of sides, is equal to 5. And this will never ever change whether we have a regular or an irregular polygon. They're asking us to prove the angle 118. Explain how you can tell from the size of the angle that this pentagon is not regular. Basically, we're going to say if it is a regular pentagon, then n is always equal to 5, whether it's regular or irregular. The formulas that are applicable only on regular pentagons are E, which is the external angle, is equal to 360 over n, which is the number of sides. Let's substitute n here, so it will be 360 over 5, and the answer will come down to 72 degrees. And if we extend this line here, the 72 degrees is here, and this is the internal angle. The other applicable rule on regular polygons, I is equal to 180 minus E. And so 180 minus E, which is 72, then the interior angle comes down to 108 degrees. So this angle is 108 degrees. So if this polygon was a regular pentagon, then the interior angle should be 108 and not 118. So this is the explanation. So the interior angle of a regular pentagon is equal to 108 degrees and not 118 degrees. Okay, the conversion of 15 miles into kilometers. So we need to memorize the following fact. 1 mile is equal to 1.609 kilometer. And if I have 50 miles, we place miles under miles is equal, this is my unknown, and then we cross multiply. So your unknown x is equal to fraction line, x is multiplied by 1, so the 1 goes down, the other two numbers goes up, multiplied by each other. Accordingly, the answer will be, the answer will be 24. Sorry about this. It's 15 times 1.609, and the answer will be 24.135 kilometer. Okay, Sandra takes an 80-mile train journey from Wellington to Palmerston North. Change the distance into kilometer. So we will write down the fact once again. 1 mile is equal to 1 mile is equal to 1.609 kilometer, and we have 80 mile here. It's equal, this is my unknown, cross multiply, so x is equal to fraction line, the x is multiplied by 1, so it goes down, and then the other two numbers 1.609 times 80 go up, multiplied by each other. The answer will come down to 128.72 kilometer. The diagram shows a triangular prism, as we can see here, and they want us to draw a net for this prism. The base is drawn for us. So the base, which is, let's say that this is the 2 centimeter, this is the 3 centimeter. Let's start with the rectangle. So as you can see here, the 2 centimeters, they drew them using 4 squares, 1, 2, 3, 4. So if you want to draw the 1.5, it will be 3 squares. So 1, 2, 3, and then you connect this point with this point. So this side is 1, it's 1.5, okay? We're going to draw the exact same on this side, so it's 1, 2, 3, connect, and this side is 1, it's 1.5, okay? The back is this piece here, the back, it's a rectangle, and the dimensions for it is 3 times 1.5, okay? So we're going to say here 1, 2, 3, 4, sorry, so it's 3 because it's 1.5, so 1, 2, 3, and this side is 3, and 1, 2, 3, so this is 1.5, and this is 1.5, this is 3, and this is 3. The last piece is the top piece, which is this one here. Or the ceiling, if you want to call it. The dimensions for it is 2.5 times 3. The 2.5 will become 5 centimeters. So 1, 2, 3, 4, 5. And here 1, 2, 3, 4, 5, 6. This is the 3 centimeters. So this one is 2.5, 2.5, 3. This one should be 2.5 as well, and this one should be 2.5, and this is the net in order to build this 3D prism. Okay, find the surface area and the volume. In order to find the surface area, we're going to cut it into pieces. Okay, let's start with the triangles at first. Let's start with the triangles. So we're going to say this is the triangle, right? And the dimensions 2 and 1 and 1.5. Okay, and you know that the area of a triangle is half times the base times the height, and here it will be half times 2 times 1.5. So the answer will be 1 0.5 centimeter squared. Okay, and then we're going to take the base that is sitting on the floor. Let's take this one, the rectangle that is sitting on the floor. This piece, the dimensions for it is 2 times 3, and it's a rectangle. So it will be, rectangle is base times height. So it will be 2 times 3. So it will be 6 centimeter squared. And then let's take the back piece here, which is this one. The dimensions of this piece is 1.5 and 3. So 1.5 and 3. So the area here is base times height. So it will be 3 times 1.5. And the answer is 3 times 1.5. It will be 4.5 centimeter squared. And do we still have any pieces? Yeah, we have the piece on the top, which is the top piece. The dimensions for it is 2.5 and 3. So it's a rectangle. Three and 2.5. So the area of the rectangle is base times height. So it will be 3 times 2.5. And the answer for this one is 7.5 centimeter squared. And then the surface area is when you calculate the area of each side, then you add the area, all the areas. So the surface area is equal to, we have this rectangle which has an area of 1.5. We're going to multiply it by 2 because we have two pieces of this triangle, plus 6 plus 4.5 plus 7.5. And if you calculate this here, so it will be 3 plus 6 plus 4.5 plus 7.5, and the answer will be 21 centimeter squared. And this is the surface area. Okay, in order for you to draw the plan, it's the top view. So this is what you're going to see. This is what you're going to see. And this is what you're going to see if you're drawing the plan. And accordingly, the drawing will end up as and then the front side, you're going to see this. and you're going to see this. So accordingly, the drawing is going to be as following. And if we're talking about the side, then we're going to see all this and this piece here. Okay, and how do we draw this? We draw it as following. Okay, if we go to this piece, the plan, it's the top view, so you're going to see this face and this one and this one. And how do we draw this? It will be drawn as following. Okay, and then the front view, you're going to see this flipped T shape, so it's going to look something like this. And then the side, you are going to see this and this face only, and we are going to draw it as following. Okay, in this shape, you're going to see this, and this, the plan. And how do we draw this? It will be drawn as following. And the front, this is the front, so it's going to look like a stair. And how are we going to draw this? It's going to be like this. And then the side, you're going to see this, this, and this. And how do we draw this? It will look something like this. Last shape, so the top view or the plan, you're going to see this, this, and this. And how do we draw this? We're going to draw it as following. And then the front, you're going to see this L shape here, and you draw it this way. And then the side, you're going to see this here, and you basically draw it like this. Okay, Naomi draws a tessellation using only one type of regular polygon. 3 of these polygons meet at a point in her tessellation. Name the regular polygon that Naomi uses. So in order to answer this question, let's start with the first polygon, such as pentagon. The number of sides in a pentagon is 5, and the exterior angle is 360 over n, so it's 360 over 5, and it will come down to 72 degrees. And then the interior angle is 180 minus 72, so it will come down to 108 degrees. So they said here one type of a regular polygon, and 3 of these polygons meet. So we're going to say 3 times I, it will come down to 324. And the 324 is not equal to 360 degrees. So we cannot make a tessellation, which is a pattern without having gaps using pentagon. If we go to the hexagon, so the number of sides is 6. The exterior angle is 60 degrees, which is 360 divided by 6. And then the interior angle is 180 minus E, which is 180 minus 60, so it will come down to 120. 3 hexagons at a point, so it will be 3 times the interior angle, which is I. So it will be 3 times 120, so it will be 360. And if it's equal to 360, then the name of the regular polygon is hexagon. Which of the following shapes do not tessellate? Tessellate, like I explained earlier, is making a pattern using this one of these shapes, or using a shape or a certain shape, creating a pattern without having gaps. So square, it will tessellate. Rectangle, it will tessellate. Octagon, it will tessellate. So it's only the circle and the pentagon that will not tessellate. A man has a mass of 120 kilograms. A bus has a mass of 17 tons. A rhinoceros beetle can lift an object 850 times its own body mass. Work out the number of buses the man could lift if he could lift 850 of his own body. Okay, so we're going to say that 850 times. So one time, if he's going to lift a mass, so it will be the same mass of his own body. Okay, and if he lifted 850 times, how many kilograms would he be lifting? So this is my unknown. We're going to cross multiply. So x is equal to, the one will go down, and then here it's 120 times 850, and the answer will be 102,000 kilograms. Okay, and the 1 ton, this is something that we should memorize, is equal to 1,000 kilogram. So if we are lifting 102,000 kilograms, what is it equal to as tons? So we place the unequal under tons, and then we perform cross multiplication. So y is equal to 102,000 times 1 over 1,000. So it's equal to 102 tons. Okay, if we read the question, work out the number of buses. So in one bus, Okay, a bus has a mass of 17 tons. Okay, so one bus can carry 17 tons. So 6 buses sorry. So one bus can carry 17 tons. So how many buses do we need for the 102 tons? So this is my unknown. We cross multiply. So W is equal to, W is multiplied by 17, so it goes down. The other two numbers go up, multiplied by each other. So 102 divided by 17, 102 divided by 17, the answer will be 6 buses. Calculate the volume of gold used to make this ring. So we are going to imagine as if we have a big cylinder and a small cylinder. So we're going to say the big cylinder, we need the radius for it. It's 1.5 centimeter, and the height is 3 millimeter. Of course, we need to make conversions. So 1 centimeter is equal to 10 millimeter. So to convert 3 millimeters to centimeter, we're going to divide by 10, so it will be 0.3 centimeter. So the volume is area of the circle times the height. So it will be pi times 1.5 squared times 0.3. So the answer here is shift pi times 1.5 times 1.5 times 0.3. So the answer will be 27 over 40 pi centimeter cubic. This is for the big cylinder. And if we want to calculate for the small cylinder, so the radius is equal to, as you can see, I'm sorry. So here there is one mistake. The radius is 1.5 divided by 2. So 1.5 divided by 2, it will be 0.75 centimeters. Sorry about that. So here we're going to replace this by 0.75. So shift pi times 0.75 squared times 0.3, it will be 0.53014376003 centimeter cubic. And then the small cylinder, the radius is not 1, it's 0.5, so it will be 1 centimeter divided by 2, so it will be 0.5 centimeter. The height is the same, 3 millimeter. To convert millimeters to centimeters, we divide by 10, so it will be 0.3 centimeter. And the volume is area of the circle times the height, so it's equal to pi times r, which is 0.5 squared, times the height, which is 0.3. So it will be shift pi times 0.5 squared times 0.3. So the answer will be 3 over 40 pi centimeter cubic. And in order to find, as you can see, we have to subtract, this is the small cylinder, we have to subtract the small cylinder from the big cylinder in order to find the volume of gold that is used in making this ring. So the volume of gold is equal to volume of big cylinder minus volume of the small cylinder. And here you're going to say 0.530143763 minus volume of the small cylinder is 3 over 40 pi. So if you insert this in the calculator as following, it will come down to 0.295 centimeter cubic, and this is correct to 3 significant figures. The volume of the cylinder, so the volume is given to us as 2,855, work out the height, and so volume of the cylinder is equal to 2,855 centimeter cubic. The radius is equal to 8 centimeter. H is the unknown, so the volume of the cylinder equals area of the base, or of the, let me write it here, of the circular base times the height. The volume is 2,855. Area of the circular base is pi times 8 squared times h. So h is 2,855 when we apply opposite operation, divided by pi times 8 squared. And if you insert this in the calculator, you will end up with h is equal to 14.2 centimeter. And here they want us to calculate the surface area. So a cylinder is made of 2 circles, the base and the top. So we have the radius for it as 6 centimeter, and the radius here is equal to 6 centimeter plus the lateral, the part that we wrap around the 2 circles. So the height from here to here, it's 12. The other side, it's 2 pi r. So it's 2 pi times 6. Okay, so in order to calculate for the area for the circle, it's pi times r squared, so times 6 squared, plus pi times 6 squared. The lateral is a rectangle, so it will be 12 times 2 pi times the radius, which is 6. And if you insert all this in the calculator, you will find it in terms of pi as 432 pi centimeter squared, and correct to 1 decimal place, it will be 1357.2 centimeter squared, and this is correct to 1 decimal place. They're asking here for 3 significant figures. How do we find this? So it's 1, 2, 3. You stop at the 5. Look at the, so it will be 1, 3. The 7 will bring my 5 up to 6. So, and it's 0 here, centimeter squared. And this is to 3 significant figures. They want us to calculate the surface area. Yeah, so we did. If the volume of a cube, so the volume of a cube, it's the side to the power of 3. They give us the volume as 729 equals to s to the power of 3. You're going to cube root each side in order to find the 1s. So s will come down to 9. And in order to calculate the surface area of a cube, so the area of one face is 9 to the power of 2, the side to the power of 2. How many faces, how many typical faces do we have in a cube? It's 6 faces. So 6 times 81, the answer will be 486 centimeters squared. And of course, the side is in centimeters. The volume of this rectangular prism is 60 centimeter cubic. What is the missing measurement? So here it represents the height. So the volume of this prism is area of the base that is sitting on the floor times the height. So they gave us the volume as 60 centimeter cubic. The base is 3 times 5 times the height. And the height, if we apply opposite operations, it will be 60 over 15. So H is 4 centimeter. So if we find this as 4 centimeter, okay, and we know that you have 2 ways to calculate the volume. So you either in millimeter cubic, I mean. So the 1 centimeter is equal to 10 millimeter. Okay, so it's equal to 10 millimeter. So this one is equal to 0.4 centimeter. This one is equal to 0.5 centimeter, and this side is equal to sorry. So they're given in centimeters. So in order to convert centimeter to millimeter, so you're going to multiply this by 10. So it will be 40 millimeter, 50 millimeter, and 30 millimeter. And then the volume, it will be area of the base times the height. So it will be 30 times 50 times 40. So it's 30 times 50 times 40. It will be 60,000. So it's 60,000 millimeter cubic. Or The volume is given to us in the question up there as 60 centimeter cubic. So the fact states that every 1 centimeter is equal to 10 millimeter. If you take all this to the power of 3, so it will be 1 times 1 times 1, so it will be 1 to the power of 3 centimeter cubic, and 10 times 10 times 10, so it's 1,000 millimeter cubic, right? And what's given to us? The 60 centimeter cubic. So we will place 60 centimeter cubic under centimeter cubic, and this will be my unknown. Let's cross multiply. So x is equal to fraction line. The x is multiplied by 1 cubic, and the other two numbers are 60 times 1,000. So the final answer will be 60,000 millimeter cubic. Find its surface area in meter squared and millimeter. Okay, so this one here is equal, as we explained, it's 4 centimeter, and there is a fact, every 1 meter is equal to 100 centimeter. So we're going to divide each side by 100. So this one, it will be 0.04 meter. And this one here, it will be 0.05 meter. And this one, it will be 0.03 meter. Okay, and then the surface area. We have the face that is sitting on the floor and the top, 2 pieces. The area for it is 0.03 times 0.05 plus the front and the back, 2 pieces. The dimensions for it is 0.04 times 0.05 plus the last 2 pieces is the sides. This one here, 2 times the dimensions for it is 0.03 times 0.04. So it's 2 times 0.03 times 0.05 plus 2 times 0.04 times 0.05 plus 2 times 0.03 times 0.04, and the answer will be 9.4 times 10 to the power of -3 meter squared. And the surface area in millimeters, it will be 2 times 30 times 50 plus 2 times 40 times 50 plus 2 times 30 times 40. So 2 times 30 times 50 plus 2 times 40 times 50 plus 2 times 30 times 40, and the answer will be 9,400 millimeter squared. And if we go to the angles here, we're going to use the rule sum of interior angles is equal to number of sides minus 2 times 180. So if we start at x, so it will be x plus sum, it means the addition, plus 2x plus 100 plus 140 plus 100 again is equal number of sides 1, 2, 3, 4, 5. So it's 5 minus 2 times 180. And if you simplify here, it will be x plus 2x, it's 3x. If you add the numbers, they will come down to 340. And then 3 times 180, it will be 540. So x is equal to 540 minus 340 over 3. So x is equal to 66.7 degrees, and this is correct to 3 significant figures. So, and if you multiply this by 2, so so 2x is equal to 2 times 200 over 3. So it will be 133.3 degrees. And that's how we find x and the 2x. Okay, and let's go now to this one here. Okay, I need to erase this. So that we can answer the questions here. Okay. Okay. So here, as you can see, we have x as an interior angle. So I'm going to name this as y, the exterior angle. And we're going to use the rule, the sum of exterior angles is always equal to 360 degrees in a polygon. So the exterior angle, let's start with y. So y plus 35, it's like I'm going in a circle, plus 50, plus 20, plus the 125 should be equal to 360 degrees. Now, if you add these numbers together, it will be y plus 230 is equal to 360. And if you apply opposite operation, or if you subtract the 230 from 360, you will end up with y is equal to 130 degrees. Y is an exterior angle, and the interior and exterior angle, they always add up to 180. So x is equal to 180 minus 130, and it is equal to 50 degrees. This is x. This is one way of finding it. Another way, now if you say here 180 minus 125, because this is an exterior angle, the interior angle here, it will come down to 55. So this is the exterior angle, and the interior angle here, it's 180 minus 20, so it will be 160 degrees. Here it will be 130 degrees, and this one here, it will be 145 degrees, because 180 minus 35, it will be 145 degrees. So the sum of the interior angles is equal to n minus 2n, the number of sides, minus 2 times 180. So x is the unknown, plus 145 plus 130 degrees plus 160 degrees plus the 55 is equal to number of sides. It's 1, 2, 3, 4, 5. So it's 5 minus 2 times 180. So here we're going to say or, another way. Okay, now you will say x plus, if you add these numbers together, they will come down to 490, and then 3 times 180, it will be 540. And if you apply opposite operations, or if you subtract the 490 from 540, the answer will come down again to 50 degrees. Now, if you go to this one, you have x and 3x and 2x as interior angles. 40 is an exterior angle, so this is an exterior angle. So if you subtract it from 180, it will be 140, the interior angle. And the 30 as an exterior angle, if you subtract it from 180, it will come down to 150 degrees. The sum of interior angles is equal to number of sides minus 2 times the 180 degrees. So let's start with x, and let's go around inside the shape, plus 3x plus 2x plus 150 degrees plus 140 degrees is equal to number of sides. It's 1, 2, 3, 4, 5, 5. And if you notice, the number of sides equals the number of angles that you added. 1, 2, 3, 4, 5. So 5 minus 2 times 180 degrees. If you add the x, 3x and 2x, they will come down to 6x plus 150 and 140, they will come down to 290, and then 3 times 180, it will be 540. Apply opposite operations, so x, it will be 540 minus 290 divided by 6. So x will come down to 125 over 3 degrees. Okay, and this is the x, 3x. It will be 3 times 125 over 3. It will come down to 125 degrees. And if you want to find the 2x, So it will be 2 times 125 over 3, and the answer will be 250 over 3 degrees. This, if you want to round it to, let's say, 3 significant figures, so it will be 41.7 degrees, 3 significant figures. And if you want to round this one as well to 3 significant figures, it will be 83.3 degrees, 3 significant figures. Here we are going to apply again the sum of interior angles. Sum of interior angles is equal to number of sides minus 2 times 180. And let's start from here and go around. So x plus, the angles are given to us as expressions, 2x minus 2 plus x minus 5 plus x minus 6 plus 2x minus 7 is equal to 1, 2, 3, 4, 5. So 5 sides minus 2 times 180. And remember, the number of sides equals the number of angles that you added. 1, 2, 3, 4, 5. Now, if you collect like terms, x plus 2x plus x plus x plus 2x, you will end up with 7x. And then minus 2 minus 5 minus 6 minus 7, it will be minus 20. And 3 times 180, it will come down to 540. And to find the 1x, it will be 540 plus 20 divided by 7. So x is equal to 80 degrees. So we found one of the angles as x is equal to 80. The other angle is given to us as an expression 2x minus 2. 2x minus 2. So it will be 2 times 80 minus 2. And this will come down to 158. The other angle is given to us as x minus 5, so it will be 80 minus 5, and this will come down to 75 degrees. And another angle is given as an expression x minus 6, so it will be 80 minus 6. So 80 minus 6, it will be 74 degrees. And then the last angle is given as 2x minus 7. So it will be 2 times 80 minus 7. And the answer will be 1. Hold on, please. So 2 times 80 minus 7, it will be 153 degrees. One 153 degrees. Okay. Here we have an interior angle given as an expression. So the interior angle is given as 10x plus 4. How many of these interior angles we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 of these interior angles. So 10 times I, which means 10 times 10x plus 4, right? If you expand, it will be 100x plus 40. So this is 10i, right? Okay, so the sum of the interior angles is equal number of sides minus 2 times 180. So instead of saying 10x plus 4 plus 10x plus 4 10 times, we're going to say 10 times 10x plus 4. Number of sides is 10 minus 2 times 180. If you expand, 100x plus 40 is equal to 9 times 180. 9 times 180, it will be 1620. And if you apply opposite operations, you will say 1620 minus 40 divided by 100 is equal to x. And so x is going to be equal to 79 over 5 degrees, which is equal to 15.8 degrees. So if x is equal to 15.8, then the one angle is 10x plus 4 is equal to 10 times 15.8 plus 4. And accordingly, this will come down to 162 degrees. So the one angle in this polygon is equal to 162 degrees. And now here we have interior angles, and this is the exterior angle x. So how many of the exterior angles do we have? 1, 2, 3, 4, 5, 6, 7. So the exterior angle is equal to x. We have 7 exterior angles, so it's equal to 7x. So the sum of exterior angles is equal to 360. So it will be 7x is equal to 360. If we apply opposite operations, so x, it will be 360 divided by 7. So it will be 51.4 degrees. Okay. Here we're going to apply the parallel line rules. So as you can see, this is a parallel line and this is a parallel line. So if we look at the given angles 80, if you go on the parallel line, the line that is crossing both parallel lines, and on the other parallel line, can you see the z angle here? So this, the z angle. So we're going to say x is equal to 80 degrees. You say z angles or alternate angles are equal. Okay, and another thing that we should notice here, that if you can you see the u here and the tummy of the u, these two angles add up to 180. So y plus 85 equals to 180. Why? We call them co-interior angles. They're not equal, they add up to 180. Accordingly, y is equal to 180 minus 85, and 180 minus 85, it will be 95 degrees. And if we go to this shape here, we have again parallel lines. Let's start with what's given. Sometimes maybe we need to find multiple angles in order to find the angle that we are looking for. So if we call this angle, for example, as B, And if we call this angle as C, okay? All right, so let's start with angle B. So you're going to say angle B, 70, angle B, you're going to say angle B plus 70, they add up to 180. Angles on straight line add up to 180. So B is equal to 110 degrees, right? Okay, if this is 110 and same applies to angle C, right? We're going to say C plus 135 degrees is equal to 180 degrees. And why is that? Because angles on straight line. So C is equal to 180 minus 135. So 180 minus 135, it will come down to 45 degrees. So if we can, so if we found C, can you see here? Parallel line, the line that is crossing both parallel lines, and another parallel line. Can you see the Z? Can you see the Z? So we're going to say A is equal to C and it's equal to 45 degrees. Why? Z angles, or we call them alternate angles. Or another way that we can find it, we can say here we can say that, okay, this, let me use another color. Okay, this is an A, and here this is an A. No, sorry. Well, this is the only way that we can find it, okay? If we go here, we also have parallel lines. So if you look, parallel line, the line that is crossing both parallel lines, this is an A. And parallel line, the line that is crossing both, and this is an A. So N is equal to 60 corresponding, or A angles. Corresponding angles are equal, okay? And if we go here, a fish tank in the shape of a cuboid has a length of 60, depth as shown on the diagram. Find the capacity in liters. So let's find first when they say the capacity, it's the volume. So the volume is area of the base, since it's a rectangular prism, the base that it is the face that is sitting on the floor, times the height. So it's 60 times 30 times 30, which is the height, and this will come down to 54,000 centimeter cubic. So this is the volume in centimeter cubic, but in every 1 liter is equal to 1,000 centimeter cubic. So we place the number that we found, 54,000 centimeter cubic under centimeter cubic, and this is my unknown. Let's cross multiply. So X is equal to it's multiplied by 1,000, so the 1,000 will go down, and 1 times 54,000. So the answer will be, if you do cancellations, it will be 54 liter is the capacity of this cuboid or tank. Now, here in the end, they're asking, the fish tank contains 47.7 liters of water. Find the height of the water. Okay. Okay, let's say here, so we're going to say if V is equal to 47.7 liters, which is the volume of water that we are going to place in this tank, and we need to find the height, and every 1 liter is equal to 1,000 centimeter cubic. So we're going to place 47.7 liter under liter, and this is my unknown. Let's cross multiply. So y is multiplied by 1, so the 1 will go down. The 1,000 multiplied by the 47.7 are gonna go up, and this will be equal to 47,700 centimeter cubic. And if we're going to place it in the tank, then the area of the base will not change. It will be always 30 times 60. So we're going to say the volume of the water is equal to area of the base times the height. The volume of the water is 47 and 700. Area of the base, as we said, the base of the tank will never change. It's 30 times 60 times the height of the water. So if you apply opposite operation, then the height of the water, it will be 47,700 divided by 30 times 60. And if you calculate here, it will be 26.5 centimeter. And we came to the end of our video. I hope you find this useful. Please do solve this worksheet multiple times, or as many times as you need to, until you actually nail it. Thank you once again for watching, and I will see you in the next video sometime soon. Good luck at your examination on Sunday. Bye-bye.